All right, simple science here. We're going to talk about work and power and mass and force and energy, and we'll start with work. So, what is work? Well, it's the ability to do something. When you move something, that's what work is. So, we see this guy trying to lift a boulder. Well, he's trying to push a boulder, right? We're talking about a Greek myth. This is Sisyphus. So, let's write Sisyphus. Make sure we have our pen ready. So, Sisyphus in the myth, he was this king and he tried to cheat death. And so, got the gods angry, right? The Greek gods got angry. Maybe it was Hades. Who knows? Maybe it was Hades, right? Hades got mad. And so he punished Sisyphus he had to roll a boulder up a hill for eternity, right? So anyway, so here's Sisyphus, there he is, and he's doing work. Well, is he doing work? He doesn't do work unless you see movement. The boulder has to move. So if the boulder moves, let's pretend the boulder is moving, then Sisyphus is doing work. So again, with work, you need to move something. So this girl obviously has no energy. She has no energy and she's not doing anything, right? So she's not moving anything. So work requires movement. But of course, like this picture right here, you need energy. And I think that's common sense. We all need energy to do something, right? So before we go to school, we have breakfast. Otherwise, we feel tired. We feel like we can't do anything. And there's two main types of energy. There's kinetic energy, and we're going to talk about force in a minute. Force wanted to come into the picture, right? It's forcing its way into the picture. Well, we'll talk about force. But energy, again, there's kinetic energy, and there's potential energy. And that's really the types of energy. And other energies fall within that. So kinetic energy is the energy of movement, and potential energy is the stored energy. All right, so when we have our breakfast, we're taking that stored energy so we can move with kinetic energy. So let's go back to Sisyphus, see what he's doing. And he's still lifting, still pushing the boulder. So he's doing work because the boulder is moving. The boulder is moving. And of course, he won't be able to do this unless he has energy. So we're assuming that he had his breakfast. He had lunch. Maybe he had a meatball hero. So he needs his energy so he could move the boulder. But he needs other things too. He needs force. What is force? Now we'll talk about force. Let's go to those two linemen we saw. Okay, so here's these one's an offensive lineman, one's a defensive lineman, who knows. So force is let's make sure we have our pen ready, and we'll change it to purple. It's a push or pull, right? It's a push or pull of an object. And if you could pull more than the other person, or if you can push more than the other person, then you have more force. And usually, sometimes you relate that to strength. You have more strength. And then again, it's not always the case, right? This person over here, let's say this person with the white helmet here, we'll give it a little one. That person could be low in energy, right? So energy is involved also. If they had this equal amount of energy and this person over here, right, number two, if this person was able to push this person out of the way, then maybe you can say he's stronger. But then again, there's other factors involved. So again, it's a push and pull of an object. It's an applying force. And there's many types of forces also. So as you can see, maybe this person can't push this box because maybe it's too heavy. Maybe its mass is too much. Let's say it's 300 pounds, whatever the case may be. And let's say he just can't push it. He's not strong enough. He's not as strong as Sisyphus or Hercules or whoever. Or there may be other factors. Maybe it's because there's also friction involved. Because friction is a force also. Friction could also cause things uh, to not move. So, in a sense, we can think of force as strength. Now, let's do another example. So here we have a pickup and a little small car. And let's say that they wanted to, let's say that they were towing something. Let's get our pen there. We'll talk about mass in a minute. Mass wants to come back. Well, not come back. We haven't talked about it yet. But let's say now that, and using purple, that this tow truck is going to push this gigantic, whatever this thing may be. And let's say the car wants to do it also. Who, in your own common sense, who will be able to, or what will be able to pull it? Well, the car or the pickup? Well, the pickup has more strength, right? And there's another thing it has more power, which we're going to talk about in a minute. Talk about power. But they both need energy, right? So they both need gas. Gas is their energy, right? Unless they're electric vehicles and they need electric, right? For their energy. But they need gas for energy. So this pickup will not move anything unless it has energy. So when it moves this object, it's doing work because the object is moving. If the object moves, it does work. If it has energy, it could move it. If it doesn't have energy, it can't move it. The pickup has a lot more power, a lot more strength, a lot more force power. So it'll be able to move this a lot better than this small car. But it brings up the question of power. Let's talk about power now. Okay, so power is the ability, let's write this down. It's the ability to do work faster. So let's say we had this log here, and we had some kind of saw, some electric saw, whatever this thing is. Here's the cord, and we had another one over here, right? Different type, Model B, and they were both plugged into the wall. And let's say that this saw, so that we have two saws here, two electric saws, and this saw was able to do it in 5 minutes. And this saw was able to do it in 1 minute. Well, then we can say that saw B is more powerful because it was able to do work faster than saw A. So the ability to do work quickly is power. So let's go back to Sisyphus. Well, first let's go to the cars. Let's say that the pickup truck was able to get our pen going. It was able to move an object. So we'll say the truck moved an object, and let's say it moved the object 10 feet, and it took 10 seconds, whatever the case. But the little car, let's say it was able to move the same object. It did it. Move the same object 10 feet, but took maybe, let's say, 1 minute. Took 1 minute to do it. So obviously the truck is more powerful because it was able to move it faster, in a faster rate. All right, back to Sisyphus. So again, he's doing work. Why? Why is he doing work? Because he's doing work because he's moving the boulder. Moving the boulder. And the boulder has mass. So mass is just as how much matter is in the object. So in a way, you can think of mass as how heavy something is. Now, in school, sometimes they confuse mass and weight. And sometimes they actually use mass for weight. But weight is dependent on gravity, mass is not. But for this video, we'll just say how heavy something is. So we know the mass. We know he's working because he's moving the boulder. We know he has energy, or else he wouldn't be able to move the boulder. So he had his breakfast, so we know we have our energy, right? We know he's doing a push and pull. He's pushing, he's not pulling, he's pushing the boulder, so he has this force. And, there is friction. Right here is friction. There's a friction force. It would be a lot easier to push this if it was a smoother surface, right? but there's a lot of friction here. And then what about power? So if he was able to push this boulder, let's say he pushed it in, let's say it took him 1 day to do it. And let's say someone else took over, maybe Hercules came to town. And Hercules did it in, 12 hours. Well, then we can say Hercules has more power than Sisyphus. But there's other factors involved too. So, Sisyphus could have taken a day because he loses energy more quickly than Hercules. Or he could have taken a day and Hercules took half a day because Hercules is stronger and has more energy anyway. Maybe he's more energy efficient. But those are basically what each one is. All right, that's simple science.